Hello. I had a few students asking questions about lesson 5.5 and how to go from the graph to the symbolic form of sine, either a function of sine or down here on 47 through 50, it's like a function of sine or a function of cosine. And what I kind of did was I tried to act like I was a student again and how I would play around with this. So one thing you could do is you could go through and put in the ones that you did over here in these earlier ones where I gave you the equation and asked you to find the graph. You could put those in and kind of play around with like, what does translating and changing things here in the symbols do to the graph? And that will kind of help you play around with it. So I'm going to show you what I would do for like, say, number 43. So for one, sine, I know, looks something like this. So I'm going to go to my Desmos so you can see what that would look like. So in the Desmos link for 5.5, you can see the sine graph starts at 0 at 0. And then at 3 pi over 2, which if we go to 3, and I'm just gonna pi over 2. So, and then also pi over 2 really is what we want to look at. So pi over 2 is 1.57. So at about 1.57, sine should be at 1. And you can see it is at about 1.57, it's at 1. Okay, so this is your natural sine curve. Okay. And I'm just showing you just what some things do to sine. So the natural sine, so you can see here in 45, we have the sine plus pi. So I'm just going to take, and I'm going to delete that, and I'm going to say, let's just graph that one. So if I just take the natural sine curve and I say subtract 1, I'm shifting everything down 1. So notice that the curve looks exactly the same shape. It's just shifted down 1. Okay. Now on 45, it looks to me like instead of going up, it's going down when I look at the graph. So let me go back to the page so you can see what I'm talking about. So here on 45, you can see where I want that sine, I want it to go up. So I need to shift everything over so it starts and goes up and then comes down like the natural sine curve, because that's what I want it to. I want to know how far do I have to shift to get it to do that. So it looks like if I shift back to this pi, negative pi or pi, I'm going to be at that 0, and then it's going to go up and down. So I'm going to shift it pi. Let me go back to my Desmos here for a minute. I'm going to say plus, and then in my keyboard menu, I can just go down here and click on the pi's. Oops. There we go. The pi. Okay, now you can see what it did is I'm going to actually zoom out so it kind of looks more like the book. So you can see that it is shifted down. The green one is shifted down. And at -1, this is at a -1, and then it goes down and then it comes back up again. And we would, I'd have to change my scaling to get it to look just like it does in the book. Now, so let's look at 43. So 43, it is starting at 0, but it is going up to 1. It is, everything is shifted up 1. It looks like, so I'm going to do another one in here. And I'm going to turn off that one. So I've just got my regular sign, and I'm going to do y equals sine of x plus 1. I'm going to see what that looks like. Okay. But I need it to go to 2 and still start at 0. Okay. And start at 0. So what can I do inside here to do that? So if I go back at pi over 2 minus pi over 2. Parentheses here. Oh, whoops. I want that to be afterward. There we go. Okay. So the purple one is, it's still at 0. If we shift it a pi over 2, it's still at 0, and then it goes up whatever it is at pi over 2, and then goes up 1 after that. So that's how we get that to be a 2. So it's all about playing around with it. So on number 47, let's go back to the book for a moment. So on 47, it's asking us to either use an a sine b of x or a cosine b of x. Well, the b actually shrinks it, like makes it skinnier or makes it flatter. So notice how on 53 and 54, these are much more spread out in 52. Okay. And then the ones on 47 and 48 are much skinnier. Okay. That is going to be due to the A and the B. So let's look at 47 here. So if we go back to our Desmos, on 47, because sine is naturally 0 at 0, I'm going to try sine as my first one. So I'm going to turn off this. So on 47 here, okay, so on 47, I've already got that one in my Desmos here. So I'm going to say, what if I just, because it goes all the way up to 3 at pi over 4. And sine is at pi over 2, sine is usually 1. So it's shrunk it a little bit. So it looks like it's from pi over 2 to pi over 4, it has doubled the pi over 2. So it's made it 2 times as fast. So let's just see. I'm going to take that 3 away and just see what this looks like. Let's just see the graph here. So it's still at 0. And now at pi over 2. Let's see what pi over 2 looks like as far as a number. Pi divided by 2. It's 1.57. So at 1.57, it's at 0 again. But we don't want that in black here. We want that to be, so let's just see if, how we can get that to multiply by 3. If that does that. So it goes to 3 at not quite, okay, so it's going at pi over 4. So if you click there, and that's what it did. You can see that in the graph on page 465 at pi over 4, it's 3. And that's what we're trying to get it to do. So it's just playing around with the graph to see what you have to multiply by to get it to be the thing to match the graph. And make sure if you go over here to your scaling to the top right of my screens, everybody see that if you go to the gear, the graph settings, make sure down here it's in radians. And then when you click on them, I also went to my gear and I also changed my x-axis to go, well, it kind of changed a little bit again, but you could change those to go from like 2 pi would be 6.28 and a negative 2 pi would be a negative 6.28. So you could change your scaling there if you wanted, but being in radians is the most important part. And then when you click on things, it's going to give it in radian format for you because it knows that you're doing trig functions. So that's how you can play around with that. Reach out if you have any other questions. I'm happy to help.